All right, so we are in geometry. Today's date is April 10th. Jaden?
Sorry.
Today's date is April 10th, 2019. Please put your name and date on your notes. I really like how Oscar's using the whiteboard for a way to write and still look at the board. That's pretty cool. All right, so there is a difference between adding and multiplying. Now that we're throwing multiplying into the mix, we are probably going to get confused. I'm going to try to keep us on the path as much as possible. So I'm going to add 2, 2, and 2. How many 2's do I have, and how do I treat that in terms of an answer? Anna, help us out. I have 3 2's, which is 6, yes. So that's how I write out how many 2's I have. I have 3 2's for a total of 6. What's going on, Jaden?
Nothing.
You don't want to grab it from the bottom?
That one's not sharp.
Okay. Thank you, Anna. So let me come back over here, give Anna her XP, and I need to get the marble jar up and ready. All right, what happens when I multiply now? 2 times 2 times 2. How can I rewrite that instead of just writing the answer? How can I rewrite that very similar to how I did the addition? I see one hand. I see Beverly's hand. There is Anna's marble. I see 2 hands, 3 hands. Go for it, Beverly. 2 to the third power. So 2 times, or 2 to the third power, which is what, Beverly? 2 times 2 times 2 is? Careful. 8, yes. Thank you, Beverly. And everyone else that was helping Beverly. Yes, it is indeed 8. That was the wrong button that I gave you. I'm just going to randomly give you 30 more because I messed that up. 30. All right. So notice the difference. One was an exponent, one was multiplying. That's going to be the main difference going forward. So what is this thing out front called? Quiet raise hand. That's the thing that's counting how many times you've added the same number. Quiet raised hand. What is this out front number called if this thing was a variable? It's 3. Maybe I was doing x plus x plus x. I would have 3x. What is this number out front of the variable called? I see only 2 hands. We need to get better with our vocab. I want more hands, please. Starts with a C. I'll give that hint. Does that give any more hands? Ah, there's more hands. Colby. There it is, coefficient. Thank you, Colby. And marble. All right. What is this thing called? And it's how many times you... Oh, shoot. Mr. Sindel still has not fixed this in his notes. It's how many times I multiplied the same number. Multiplied the same number. What is the thing that I'm looking for? India. The what? Pattern. Oh, power. Yes, the power. The power counts how many times you multiply the same number. Thank you, India.
If you played AYSO.
Don't know what's going on there. All right, thank you, India. All right, so that was our example. Let's go ahead and treat that same rule for our exponents. The difference between a coefficient and a power. Who can add up all of these x squared terms for me? Quiet raised hand, with or without a card. I don't care. I just want to see how many hands know this one. If I'm adding up x squared plus x squared plus x squared, this is a review from the last 2 lessons. Only 1 person out of 2 people, 3, 4 people out of a class of 18. All right, there's more hands. Oscar.
3x squared?
It is indeed 3x squared because that coefficient out front is the thing that counts the number of x squareds. Thank you, Oscar. All right. This one is a little bit trickier now. X squared times x squared times x squared. I'm counting up how many times I've multiplied these x's or these x squared terms. Ellery. It is indeed x to the 6th power. You add up these exponents. 2 plus 2 plus 2. You're adding these. So you can do a little plus sign. Since we're multiplying, you can just add the exponents. Thank you, Ellery. And marble. All right, so this is a rule of exponents that is, I guess, really distant in our past from Algebra 1. But this old rule, does anyone remember what happens when you do x to the power of n times x to the power of m? You just have the same base here. the same base. What was that old rule from Algebra 1? Anna.
X to the power of n plus m.
There it is. Thank you, Anna. N plus m. You add the exponents. This is exactly what Ellery did in our last problem. Thank you, Anna. All right, I have quite a few participation cards in already. So this is going to be our extension on that old rule now. Now I'm going to have a coefficient in front of that x to the power of n, and a coefficient, a different coefficient, in front of that x to the power of m. So what is going to happen here? And this is going to be the rule that you're going to be using over and over again for the next 3 days and technically the rest of the year. Super important rule. How does that change? Anyone want to take a stab at it? One person wants to take a stab, 2, 3 people. India, go for it.
You do a times b to the x n plus b.
Careful. N plus,
M, sorry.
yes, there it is. Xn plus m. Perfect. Yeah, thank you, India. All right, this is the rule that we need to have memorized. If there's one single rule that I can make the most important rule, I guess it's competing for another important rule. This is one of the 2 most important rules you can take away from the entire unit. Please have this memorized. It is super duper important. You multiply those coefficients and you add those exponents. These n and m were added. That a and b out front, we multiplied that out front. A and b were multiplied out front. All right, let's do that same rule with words. So these were polynomials that I was multiplying. I have a polynomial here, a polynomial here. When multiplying, we did what with the coefficients? Again, a and b were the coefficients. What operation do we do with those coefficients? I'm seeing the same old hands. I want to get some new people in here. What did we do with those a and b's? Martine. Careful here. What was this? Yeah, multiply. We multiplied. Multiply. Multiply the coefficients. Thank you, Martine. And what do we do for the exponents? Lorea, go for it. We do add the exponents. Thank you, Lorea. So if you don't like memorizing a bunch of symbols, maybe you would rather memorize the words. One of these 2 rules you have to have memorized. I personally prefer words because it's easier to memorize. A bunch of symbols kind of looks hard to memorize. All right, let's try out our new improved rule with example 1. I need to multiply these 2 things together. The difference here, there's no sign in between here. There used to be a plus or a minus in between here. Now there's no sign. That tells me I'm going to be multiplying, not adding or subtracting. So I'm going to have to use this rule that we just started, this rule in words that we just did. Someone help me out. I'm going to multiply the coefficients, 3 and 2. I'm going to multiply those, and then I'm going to add the exponents. Ellery, go for it.
You'll have 6, which is 3 times 2, x squared, or
So this old x was x to the power of 1.
so then you'll have x cubed.
X cubed. Yes, good job. Thank you, Ellery. Just making sure that everyone is following along. We multiplied the coefficients. That means that this 3 and this 2 were multiplied together. 3 times 2 is indeed 6. And then I'm going to add the exponents. The exponents were 1 and 2. 1 plus 2 equals 3. Fist of 5, how well are you following this last example? Fist of 5, I need to see what's going on here. Now, fist of 5, if you saw this type of problem on your own, how well do you think you could actually solve it?
Is there anything below?
I like the honesty. Yeah, it went down. Yeah. All right, thank you. All right, this one is a little bit difficult because we have to distribute. This negative 4k is distributed into both of these 2 terms. Who can help me distribute? I see 1 hand, 2 hands, 3 hands, 4 hands. Beverly, go for it. Yep, so we're doing this one right now. This negative 20k to the 4th power. And I'm going to pause you right there, and I'm going to have you do the second part, but let's make sure that everyone is following along. This was 4k to the 1 power, the first power. Negative 4 times 5 was negative 20. I just multiplied the coefficients. For the power, I'm just adding 1 and 3. 1 plus 3 is 4. We get negative 20k to the power 4. Okay, Beverly, continue. To the second power like that. Be careful about that power. If there was no k.
Then just negative 8k.
Yes, just negative 8k, exactly. Thank you, Beverly. Just a k. So if you have a k multiplied by something that's missing a k, just leave that k there. Another way of thinking about this that is far less common is if you do k times 2, this really is 2k to the power of 0. Anything to the power of 0 is just 1, but you can think about it adding to 0. All right, example 3, and then we're done with the notes. The back side is blank. Who can help me with example 3? All right, India, go for it.
I also have a question. Can you simplify the negative 20k to the 4th power minus 8k even further?
No, I don't think you can. I mean, you can factor it back apart, but that's as simplified as you can get.
Wait, why can't you just subtract? Because 8k doesn't have an x. They're not like terms.
Exactly, yeah, you answered it yourself. And I'll repeat that just in case anyone else is confused. We cannot add these two terms because they are not like terms. As Ellery said, this is a k to the power of 1, this is a k to the power of 4. While they are both k, which fits 1/2 of the definition, the other second part of the definition of like terms is you have to have the same power, the same exponent. Because these are different exponents, you cannot add them. Yeah, that was a good point to point out. Thank you, Ellery.
Wait, and with multiplication and division, is it also that you need like terms?
Multiplication, you just sandwich them together, you don't even care. Like terms is only when you add or subtract. All right, go for it, India.
Negative 8b squared times 4b squared is going to be negative 32b to the 4th power. And then it's going to be plus. Is it plus because both of these symbols are negative? And it's going to be 48 squared or b to the 3rd power.
Like that? Yeah, there it is. There's our final answer. And because we don't have a bunch of scratch work, you don't have to box your work. If you did multiple steps, that's when you want to box your work to say, hey, this is where the answer is. If you only write the answer, I don't think you need to box your work. All right, Fistify for the whole lesson. How well did you understand the lesson? Nice. Okay. Some 3s, mostly 5s. All right, go ahead and write your summary. Write this rule from memory. Write it from in words or write this rule. This thing needs to be in your summary, either in symbols or in words. Do that now. Everyone should be working on your summary. Either rewrite the symbols or rewrite the words. Whatever one you like more.